Hi, welcome to Physics 2.2 Vertical Motion Problems, Throwing Objects Up. So first let's go through the variables you need to consider. First one is velocity. You have several of these. The initial velocity, or v naught, is the vertical velocity the object is thrown, launched, etc. Then you have the top velocity, the vt. The vertical velocity of the object at the apex of its trajectory, its highest point. This should be 0. And finally, the final velocity, or VB, or simply V, the final velocity of the object when it returns. Then you have to deal with time. Time is the time up, which is TU, time to reach its apex, or time down, TD, which is the time to return from the apex. Acceleration is A, or G. This is the downward acceleration of gravity. Remember, once an object is in the air, the only thing acting on it is gravity, and gravity is a negative 9.8 meters per second per second. Facts to know. Now we're actually going to look at direction, okay? Instead of just dropping objects, now we're having two directions, up and down. So we've got to deal with positive and negative. So up will be positive and down will be negative. The acceleration of all objects in the air, remember, is A, or G, which is 9.8 meters per second down, or a negative 9.8 meters per second. If an object is going up in the air, the acceleration will be negative, but the velocity will be positive. If an object is going down in the air, both the acceleration and velocity will be negative. So here's a diagram, and I will be giving you copies of these things. For throwing an object up into the air, it does have some of our variables labeled. When we throw an object up from the ground, we turn the tables. The acceleration is negative. Y naught is 0 at the bottom of the path. So Y naught is here at the bottom, right? Y is at the top. And you're throwing an object straight up and back down. The arc is just so that you can see up versus down. All right, you're going to pause if you're watching this on your own, get your formula sheet. You're going to copy the next two and the only two slides. These are your three kinematics. Y is equal to Y naught plus V naught T plus 1/2 AT squared. V is equal to V naught plus AT. V squared is equal to V naught squared plus 2A delta Y. Okay, Y is in meters, Y naught is the initial height, acceleration is a negative 9.8 meters per second, so on and so forth. So this kinematic one can be used to find height. We have also rewritten it to find time, and we're going to go through more of those in class. Kinematic 2, the first one is kinematic 2 to find height. Kinematic 1 is used to find time or velocity. And kinematic 3 is used to find height or velocity. Be sure you get these on your formula sheet. I know they're already there. Example 1. An object is thrown into the air from the ground with a velocity of 3 meters per second. How long does it take to reach its highest point? So we again want kinematic 1, V is equal to V naught plus AT. Substituting in, V is 0 at the top. Remember, V naught is what you threw it at. That was a positive 3. A is a negative 9.8. Solving that for T would be 0.306 seconds. Time up would be 0.306 seconds. So then how high does it go? Well, that's Y is equal to Y naught plus V naught T plus 1/2 AT squared, or kinematic 2. Substituting in, and yes, we will have a double rounding error simply because we're using time to find height and we just found time. We'll talk more during class about how to find height when all you know is the vertical velocity. Substituting in the values that you do know should get around 0.459 meters. These are the kinds of problems you're going to be doing in class. Thanks for watching.